From the top of a 25-meter tall building, the angle of elevation of the top of the building across the street is 30 degree, while the angle of depression of the building is 25 degree. Find the height of the building across the street. Let us take this point as A, B, C, and D, and this point as E. BC is the short building, which is 25 meter in height, and C being top of the smaller building, that's where we are observing the building AE across the street, and the angle of elevation of point E, I mean the top of the building, is 30 degree. So let's draw this angle 30 degree, and angle of depression of the foot of this building is 25 degree. Angle of elevation is made when you look at a point above the level of your eye, that is called the angle of elevation, and when you look at a point below the level of your eye, that is called the angle of depression. So the angle of depression here is 25 degree and angle of elevation is 30 degree. We need to find the height of the taller building across the street, which is AE. Now BC and AD being opposite side of the rectangle, here AD is also 25 degree, 25 meter. So let's mark this as 25 meter. Okay, here this is 25, and now we will be required to find DE. If 25 degree is the angle of depression, then this angle will be equal to 65 degree, because the total angle made at point C in that corner of the rectangle is 90 degree. So this angle must be 65 degree. If we consider triangle ABC, consider triangle ABC, and here tangent is equal to, tangent is a ratio between perpendicular over base, or in other words, it's a ratio between opposite and adjacent. So side opposite to 65 degree would be called opposite, and BC is adjacent, because if this angle is 90 degree here, then AC would be the hypotenuse. So tan of 65 degree would be equal to opposite over adjacent. Opposite is AB, which we are interested in finding the value for. So tan of 65 degree is equal to AB over adjacent is BC. So this means AB is equal to, the value of BC is 25. So 25 times tan of 65 degree. And the value of tan 65 is 2.14. If we substitute the value 25 times 2.14, this will give us the value for AB, which is equal to 53.5 meter. Alright, once we have found this AB, this being opposite side of the rectangle ABCD, now this CD is equal to 53.5. This is 53.5 meter. Now we consider triangle CDE. Now we consider consider triangle CDE. CDE, because we will find DE from this, while the adjacent of this triangle is known. The side opposite to 30 degree would be opposite. This would be hypotenuse, and this 53.5 would be adjacent now. So from this triangle CDE, the angle given is 30 degree. So now we will take tan of 30 degree. Tan 30 degree is equal to DE, which is opposite, over adjacent, which is DC. This means tan of 30 degree is equal to DE, which is we are interested in finding, over 53.5, over 53.5. This means that DE will be equal to 53.5 times tan of 30 degree, tan 30 degree, and 53.5 times tan 30 is 0.57. Once we substitute this value, we will get 30.49. And we have DE now, and we already have AD, which is 25. The total length is equal to EA. Height of the building, required height of building is AE, which is equal to AD plus DE. AD plus DE. AD is equal to 25, which was kind of given already. So this is 25 plus DE. We have just calculated it 30.49. So this will give us the total value of 55.49. 55.49 meter. That is height of the building, which is just across the street.